In this video, I want to introduce you to the idea of an exponential function. Exponential function. And really just show you how fast these things can grow. So let's just write an example exponential function here. So let's say we have y is equal to 3 to the x power. Notice this isn't x to the third power. This is 3 to the x power. Our independent variable x is the actual exponent. So let's make a table here to see how quickly this thing grows. And maybe we'll graph it as well. So let's take some x values here. So let's start with x is equal to -4. Then we'll go to -3, -2, 0, 1, 2, 3, and 4. And let's figure out what our y values are going to be for each of these x values. Now, here y is going to be 3 to the -4 power, which is equal to 1 over 3 to the 4th power. 3 to the third is 27, times 3 again is 81. So this is equal to 1 over 81. When x is equal to -3, y is 3. Let me do this in a different color. That color is hard to read. Y is 3 to the -3 power. Well, that's 1 over 3 to the third power, which is equal to 1 over 27. So we're going from a super small number to a less super small number. And then 3 to the -2 power is going to be 1 over 9, right? 1 over 3 squared. And then we have 3 to the 0 power, 3 to the 0, which is just equal to 1. So we're getting a little bit larger, but we're going to see we're about to explode. Now we have 3 to the first power. That's equal to 3. Then we have 3 to the second power, right? Y is equal to 3 to the second power. That's 9. 3 to the third power, 27. 3 to the fourth power, 81. If we were to put the fifth power, 243. Let's graph this just to get an idea of how quickly we're exploding. So let me draw my axes here. Let me draw my axes. So that's my x-axis, and that is my y-axis. That is my y-axis. And let me just do it in increments of 5, because I really want to get the general shape of the graph here. So let me just draw as straight a line as I can. Let's say this is 5, 10, 15. Actually, I won't get to 81 that way. I want to get to 81. Actually, well, that's good enough. Let me draw it a little bit differently than I've drawn it. So let me draw it down here, because all of these values, you might notice, are positive values because I have a positive base. So let me draw it like this. Like that. Good enough. And then let's say I have 10, 20, 30, 40, 50, 60, 70, 80. That is 80 right there. That's 10. That's 30. That'll be good for approximation. And then let's say that this is -5. This is +5 right here. And actually, let me stretch it out a little bit more. Let's say this is -1, -2, -3, -4. And then we have 1, 2, 3, and 4. So when x is equal to 0, we're equal to 1, right? When x is equal to 0, y is equal to 1, which is right, maybe right around there. When x is equal to 1, y is equal to 3, which is maybe right around there. When x is equal to 2, y is equal to 9, which is right around there. When x is equal to 3, y is equal to 27, which is right around there. When x is equal to 4, y is equal to 81. Y is equal to 81. So you see very quickly this is just exploding. If I did 5, it'd go to 243, which wouldn't even fit on my screen. When you go to -1, we get smaller and smaller. So at -1, we're at 1/9. I mean, eventually you're not even going to see this. It's going to get closer and closer to 0. As this approaches larger and larger negative numbers, or I guess I should say smaller negative numbers. So 3 to the -1,000, 3 to the -1,000,000. We're getting numbers closer and closer to 0 without actually ever approaching 0. So as we go from -infinity, x is equal to -infinity, we're getting very close to 0. We're slowly getting ourselves away from 0. But then, bam, once we start getting to the positive numbers, we just explode. We just explode, and we keep exploding at an ever increasing rate. So the idea here is just to show you that exponential functions are really, really dramatic, that they're the kind of, well, you can always construct a faster expanding function. For example, you could say y is equal to x to the x, even faster expanding. But out of the ones that we deal with in everyday lives, this is one of the fastest. So given that, let's do some word problems that just give us an appreciation for exponential functions. So let's say that someone sends out a chain letter on, let's say in week 1. Week 1, someone sends a chain letter to 10 people. To 10 people. And the chain letter says you have to now send this chain letter to 10 more new people. And if you don't, you're going to have bad luck and your hair is going to fall out and you'll marry a frog or whatever else. So all of these people agree and they go and each send it to 10 people the next week. So in week 2, they go out and each send it to 10 more people. So each of those original 10 people are each sending out 10 more of the letters. So now 100 people have the letters, right? Each of those 10 sent out 10. So that 100 letters were sent out. So let me see. Sent. 10 were sent. Here, 100 were sent. In week 3, what's going to happen? Each of those 100 people who got this one, they are each going to send out 10, assuming that everyone is really into chain letters. So 1,000 people are going to get it. And so the general pattern here is the people who receive it. So in week n, right, where n is the week we're talking about, how many people receive the letter? In week n, we have 10 to the nth people receive I before E except after C. Receive the letter. So if I were to ask you how many people are getting the letter on the 6th week, on the 6th week, how many people are actually going to receive that letter? Well, what's 10 to the 6th power? 10 to the 6th is equal to 1 with 6 zeros, which is 1,000,000 people are going to receive that letter in just 6 weeks, just sending out 10 letters each. And obviously in the real world, most people chuck these in the basket, so you don't have this good of a hit rate. But if you did, if every 10 people you sent it to also sent it to 10 people, and so on and so forth, by the 6th week, you would have 1,000,000 people. And by the 9th week, you would have 1,000,000,000 people. And frankly, the week after that, you would run out of people. I'll see you in the next video.